In this video, I will be going over the section 9.4 Day 2 notes, and here we're writing out the equations of ellipses. Just as a quick reminder, if you have an ellipse whose major axis is horizontal, it follows this standard form equation where the a value is associated with x. And remember, a is always bigger than the b value. If you have an ellipse whose major axis is vertical, then the a value has been moved to be associated with the y value. And as always, a is the distance from the center to the vertex, b is the distance from the center to the co-vertex, and c is the distance from the center to the focus. And they're related using this equation right here. Vertices are always on the major axis. Co-vertices are always on the minor one. And the focus, or foci, are always on the major axis. And if you recall, we talked about a lot of that in our previous video using these two diagrams right here, but more importantly, using some of the not only equations, but some of these shortcuts to find those points. So today, instead of graphing, we are just going to look at answering some questions and writing out the equation. So in this particular ellipse, we know that the a value, or a squared value, is 25. And since it's associated with y, that would make our major axis vertical. Now, if a squared is 25, then a itself is 5, and so the length of the major axis is 10. It's always 2 times the a value. Now, since our ellipse is actually centered at the origin, this major axis will actually start at -5, and we'll go to +5 on the x-axis, or excuse me, on the y-axis, because it's vertical. So it kind of looks like this. So I would go 5 units up, 5 units down. That right there is going to represent our major axis with our center right here. Now the minor axis is horizontal. It's going to be shorter because it's the minor. B squared is 9, so that means B has a value of 3. So the length here would technically be 6 because it's 2 times B. And that goes from -3 to +3 right here and right here. The only thing I need to kind of talk about now, we can talk about vertices. Now the vertices are the endpoints of the major axis. Okay, so think about the major axis when you talk about the vertices. So that would be here and here. So it is 0, 5 and 0, -5. And then for the foci, those are also on the major axis. A lot of repetition here with these questions, but they're really trying to emphasize them. And I would actually have to find the c value by using this relationship here. I think c comes out to be 4. And so those would be at 0, 4 and 0, -4. They would fall right here and right here. And there it is. So just a quick review of what we talked about in the last video. All right, so let's do a couple of problems here on the back side. It says write the equation of an ellipse with the given characteristics. Number 1, I have vertices at -3, 5 and -3, -3, and the minor axis has a length of 6. So a couple things you can do. You can just kind of picture these 2 points if you wanted to. You know, maybe this point right here is -3, 5. and this point right here would be -3 comma -3. So if you look, they have the same x value. Okay, so maybe the plane would kind of run this way, but this is going to be the point -3 comma 3 and the point -3 comma 5. So this is a vertex and this is a vertex. So the center of the ellipse is going to be halfway between those. And that is also a total length of 8. So if I go 4 units in either direction, that will give me the center at -3 comma 1. That is the center. Okay, so what I kind of can assume here is the center is always h comma k, and that right there is -3 comma 1. But also, I know that the a value is 4. Now it says the minor axis has a length of 6. That's the 2b that we referred to on the front. So that implies that b has a value of 3. So that's enough to write the equation. We don't actually need the foci to write out the equation. So just to remember that this ellipse would be vertical. So I would have x plus 3 squared divided by something plus y minus 1 squared divided by something is equal to 1. The somethings are going to be a squared and b squared, and I'm going to put the a here, or the a squared here, because this is vertical. So a squared is 16, and b squared is 9. And that right there is your equation. So it might be helpful to draw some sort of a sketch with these problems just to remind yourself what direction your ellipse will be going in terms of its major axis, or to get maybe the a or the b value. Number 2, I have foci at 2, 5, and 8, 5, so that kind of runs horizontal. So let's say 2, 5, and 8, 5. So the center is still halfway between those 2 points. So if I were to do that, I believe that's a total length of 6. So then this is the point 5 comma 5, and that's your center. So I know a couple different things. I know that the center is 5 comma 5, and I know that the c value has a length of 3. Now, once again, it gives you the minor axis. It gives you its length, so that is 2b, so then that means b is 4. So you need to find a, so I am going to use the relationship c squared equals a squared minus b squared, and find the value for a squared. Okay, there it is. So then I'm going to write out my equation, which I probably should have done over here, but here we go. I have x minus 5 squared, that's from this 5, plus y minus 5 squared, same thing, equals 1, but each of those get divided by, well, since my major axis is horizontal, I'm going to put a squared first, and then b squared, which we said is 16. There's your equation. Got one more here. I have vertices that fall at -2 comma 1 and at 6 comma 1. So those are vertices. So this is the major axis. I have foci at -1 comma 1 and 5 comma 1. So there's 2 different things you can find here, or actually 3 different things that you can find here. You can find the center pretty easily. I'm going to put C down here for center. The center should be in the middle at 2 comma 1. But you also know the A value and the C value. Okay, so the A value is the distance from the center to the vertex. That looks like the A value there is 4. And the C value is the distance from the center to the focus. So it looks like that's 3. So then you're going to use that relationship here to find B, or at least find B squared. that would be 9 equals 16 minus b squared. Looks like b squared would be around 7. So I'm going to take the center, start writing out the equation. Now this is a major axis that is horizontal, so the bigger number, a squared, goes here. So that's 16. And then we know b squared is exactly 7. It's not 49, right? So b squared is 7, which would make b the square root of 7. But there's your equation right there, and I believe that's your video.